The Case of the Frozen Addicts by J. William Langston and John Palfreman. The title of this book comes from a description coined by California neurologist William Langston, who in 1982 began investigating a bizarre outbreak in 6 individuals. The patients had bent and twisted bodies. Faces were stiffened to the point that some were drooling uncontrollably. Their bodies resembled statues. These 6 frozen addicts resembled living statues, but were still aware about their surroundings. It was as if these patients' conscience was stuck inside a solid rock. It was a mystery that seemed almost unsolvable. How can coincidentally 6 patients between the ages of 30 and 40 experience Parkinson's disease at such a young age? After intensive investigation, Langston discovered that all 6 living statues had used a new form of synthetic heroin, made from a new industry where people would create designer drugs by messing around with compounds in order to replicate the same effects of illegal drugs, but was at the time cheaper priced and managed to work around the law. Langston at the time was very alarmed and concerned and called a press conference to warn of the bad drugs in the streets. But he, and along with state and federal researchers, soon discovered that what it was about the drug that was producing these startling symptoms. To neurologists like Langston, the symptoms were bizarrely familiar. The victims, frozen in their eerie poses despite the summer heat, resembled patients in the last debilitating stages of Parkinson's disease, an illness which regressively destroys muscle control. What had these drug users injected? What was the particular peculiar chemistry that had launched them into something that looked like the end stages of one of the most intractable of all neurology diseases? And if researchers could decipher what had happened to the frozen addicts, could they also decipher what was going on with Parkinson's disease? As it would turn out, the answers to these questions is a yes and a no. As Langston and his team of researchers got in depth of their investigations, they had discovered that the drug in the street was introduced by chemistry graduate student Barry Kidston from Maryland in 1977, who had also become a frozen addict. Kidston, unfortunately, became an addict to Super Demerol, a homebrewed experiment based on the chemistry of a narcotic painkiller. As researchers explored the connection between the case and the illnesses in California 5 years later, they discovered that the source of the problem was an impurity in the mixing of the chemical. That impurity was a knotted bundle of carbon, hydrogen, and nitrogen that researchers called NPTP. NPTP, as it turned out, metabolizes in the body into a targeted missile. The target is a region of the midbrain called the substantia nigra for its dark pigment. The substantia nigra contains most of the brain cells that produce the powerful neurotransmitter dopamine, essential to everything from moving muscles to feeling pleasure. It's that even worse stage that the destructive effects of NPTP can mimic so well, and as researchers like Langston realized that it could be a tool, they could use it to better understand and treat not only the frozen addicts, but the disease itself. They could, in fact, develop an animal model for the disease, which they subsequently did in monkeys. And this leads me to that yes and no part of the story. Before the frozen addicts, the only real treatment for Parkinson's disease was a drug known as L-Dopa, which simulated the production of additional dopamine in the brain, seeking to replace some of the lost neurotransmitters, which unfortunately can't be replaced like our skin cells. Once the transmitters are gone, it's permanent damage. The unfortunate part of L-Dopa was it had horrible side effects, like hallucinations or uncontrollable body spasms. The side effects were so bad that Connie, one of the 6 frozen addicts, had to be taken off of L-Dopa because her hallucinations caused her to think there were robbers consistently trying to break in her house, that she runs around screaming, while carrying a kitchen knife. Another extreme side effect was uncontrollable body movements. While L-DOPA allows Parkinson's disease patients to move, but the command of the movements from our brains is not exact. Another frozen addict of the six, Juanita, lived on a Native American reservation and was mocked by the people because each time she walked, her legs would launch like a horse. It was so bad that when she sat in a chair, she couldn't sit still and would rock uncontrollably to the point that she had to hold on to the arms of the chair in order to not fall out. This was when Langston knew that L-DOPA was not the right choice for Parkinson's patients, and how there had to be another way. Coincidentally, Langston was invited to a neurology convention and had taken a bus with 18 other suited-up neurologists from the world. While on the way there, the bus driver got lost, while also getting the tires stuck in a mud hole. The bus driver left to get help, and there left 18 dressed-up neurologists stuck in a bus in the middle of nowhere. Langston decided to walk and stretch and introduce himself to two neurologists from Sweden. The conversation went well as Langston was sharing his story about MPTP. But the Sweden neurologist, Patrik Brundin, shared his research and how he transplanted fetal neural cells and transmitters into monkeys who have been put on MPTP in order to replicate Parkinson's disease. After the test run, it was soon that the monkey's brain had accepted the fetal neural cells and could actually move. After a few years had passed since Langston and Brundin had met, the Sweden neurology team had decided to test it on humans after seeing many positives with the experimental monkeys. Brundin ended up picking Juanita and George Carrillo, another of the six frozen addicts, to get the surgery done. After the two frozen addicts came back from their operation, the results were stunning, because after time, both of them were able to move on their own and had possibly allowed them to live longer. This discovery led researchers to have found new ways of managing the disease. Some of the new treatments, such as the electrical stimulation, have been used to treat the lingering symptoms of the old frozen addicts. Count those results on the yes side. On the no side, we have not yet discovered how to cure Parkinson's disease. After having read this book, my view on scientific research has changed drastically. One would think that scientists had boring, dull jobs working at a lab institution while mixing solutions, but it's actually quite the opposite of that. From reading the summary of the book, most would probably think the book is mundane because it's under the neurological topic. But really, this book was almost like a suspenseful adventure book with little bits of drama tossed in there. The book was pretty interesting, following Langston, who was an interesting guy, because here was a guy who was bored with his work at the clinical while being on his third marriage with a child arriving. It was like true faith when the six frozen addicts became his patient, which led to the discovery of MPTP, which made his famous debut in the science world. The book also goes on about how Langston made many attempts to post an article in Science, a magazine that scientists all over the world have read. The book also goes through the process of how scientific research is posted to the public and how it can actually become really competitive when it comes to who actually gets the full credit on the new discovery. The book gets extremely interesting when Langston happens to meet the MPTP drug designer Vincent Mason on his 42nd birthday. Both men were casually having a conversation about Mason's upbringing on MPTP while eating birthday cake. The book was outright shocking at times because it had a chronological order feel to it. First, the designer drug industry creating drugs that could potentially ruin someone's life by freezing them. Then 6 individuals who sadly fell under the scam of designer drugs. An average clinical doctor who in the end discovers a drug that replicates neural disease in order to allow experiments on the brain. In my personal opinion, this book is suitable for high school students and up, and maybe even teach the reader new aspects on the science world and how new drugs and cures are discovered. Also, if someone were interested to go into neurology or in the medical field, I would totally recommend this book, as it follows the life of Langston and his research and work life, which could possibly give a glimpse on what it's like to work in the medical field. Overall, this book was exciting, keeping you on your toes while trying to read the book, hoping that there was a cure for Parkinson's disease, but also at the same time informally educating the reader on how neurological diseases happen and what goes on in the brain when these diseases take place, and how the scientific world and research works.